receiving a folder, a link to a folder that has a lot of wonderful resources that both Lisa and Paula have contributed, and I think they're going to be even sharing that link during their presentation today. We will have the chat open during the presentation, and we're going to open with a little bit of an overview of AB 1705 and some of the sort of current context within the state of California around STEM calculus and access to STEM calculus. We're not going to have a whole lot of time today to discuss or answer questions on AB 1705. We really want to try to keep the chat open to questions and discussion about what Lisa and Paula have so kindly been willing to share with us today. All right, AB 1705. A lot of information has come out from the Chancellor's Office about this new law that was signed into effect last fall. There was an implementation guide distributed in December, and they conducted a webinar in February. They this week released a 22-page FAQ from that webinar and a further implementation guidance. So we will be providing those links in the chat if you haven't already seen that. A lot of the questions that you might have today about AB 1705, I am going to bet are within those 22 pages. So we're not going to spend a lot of time trying to debate the law or answer questions about it. We're going to really try to focus today on what Lisa and Paula have been doing at their college and are offering to share with us. Okay, that said, I'm going to do some very quick cliff notes on AB 1705. On the left there, you will see the actual statute. If you want to get into the legal language, you'll know the sections that I'm referencing. AB 1705 has a new stipulation that students cannot be required to repeat courses that they previously passed. And in the guidance from the Chancellor's Office, this has been restricted to math courses, and they have quite a bit of guidance around this. So if you have questions about it, make sure that you're looking at the guidance and the FAQs. They also, in the Chancellor's Office webinar and in their guidance, are using a term that's not used in the law. It's called Gateway Math Course. This is sort of a shorthand. So a Gateway Math course is the lowest level of math that satisfies a degree or transfer requirement within a program of study. In the law, just as in previous AB 705 guidance from the Chancellor's Office, we see the stipulation that U.S. high school graduates have to be directly placed into, and when beginning math or quantitative reasoning, enrolled in a Gateway transfer level course. For all students, and this again sounds like AB 705, placement and first mass enrollment must maximize the probability that a student will enter and complete. And what's new is the Gateway course requirement. So we're no longer just talking about courses that satisfy general education requirements for quantitative reasoning. We're talking about courses that satisfy lower division major prep, right? According to what you would be doing for your associate degree. And there is an exception that students can start in prerequisite coursework before the Gateway course if the college verifies benefit to the student, and there's standards in the law about how you verify benefit. And the Chancellor's Office is referring to these exceptions as validating prerequisites. So by July of 2024, a little over a year from now, any calculus-based associate degree or transfer major in STEM can offer no more than 2 transfer level prerequisites to the first STEM calculus course. And if you're interested in validating your prerequisites, these are the 3 standards in the law. The student is highly unlikely to succeed in the first STEM calculus course without additional transfer level preparation. The enrollment will improve students' probability of completing the first STEM calculus course. And the enrollment will improve the student's persistence to and completion of the second calculus course in the STEM program if a second calculus course is required. Now, you might have a lot of questions about how validation can occur. There's 5 pages in the FAQs on this that you can read, but it's a little bit of a deja vu. If you remember back where we were before AB 705, we had a lot of pre-transfer level prerequisites that barred students access to transfer level work. And yet we had a whole mechanism that was based on validation templates that were sent from the chancellor's office, where we were validating prerequisites, even though we had not been allowing students to bypass those prerequisites. So you can get some details and reminders about that in the FAQs, but it's really a little bit of a deja vu for me. Sort of looks similar to where we've been before. All right, what happens if you can't validate your prerequisite? By July 1st of 2025, the college can no longer require or recommend a prerequisite course, and U.S. high school graduates have to begin in the Gateway transfer level course at that point, but this can be done with co-requisite support, which is what we're going to be hearing about today. Again, if you have questions, make sure you check out the FAQs, because I think they probably have your questions answered. Now, before we hear from Paula and Lisa today, I wanted to just sort of norm our shared values, because we had a lot of interest in this webinar, and I think we have a lot of math faculty here, and we are concerned about STEM. So I wanted to put up our shared values, which I'm hoping that you agree with, that we want more students and a more diverse student body to transfer in a STEM major and earn a STEM degree, right? We want more STEM majors, and we want students of color to be STEM majors. Calculus is the gateway to STEM, so we want to help more students complete calculus, right? That's part of our goals. We want our STEM math pathways to produce equitable calculus completion, and we want to remove barriers that contribute to inequity in calculus completion. I think those are probably things we can sign on to. And the last one is that we want our STEM pathways to keep the door open to a STEM major for students who are deemed not calculus ready, by producing the highest completion rates we can of calculus for that group of students. Now, I want to step back for a moment and think about, when we think about our shared values, and it's not just about getting through calculus, right? It's about STEM momentum. It's about transferring with a STEM associate degree. It is about finishing a bachelor's degree in STEM. If you look at research, and there's a lot of interesting studies on this, I picked one from the Community College Research Center, which is out of Columbia University. They looked at data from community colleges across 3 states, and they were trying to investigate with pretty rigorous statistical analysis what were the most reliable indicators of STEM transfer and bachelor's degree attainment in STEM. And guess what it is? Not surprising, right? You got to finish that calculus course in your first year at the college, or other STEM work that counts toward lower division requirements in the STEM major. And if you do that, that is a reliable predictor of whether the student will transfer and complete a bachelor's degree. And they found that the first year completion of calculus is a reliable predictor across student demographic subgroups and institutional contexts. Continuing from that study, they found that relatively few community college students actually complete this type of STEM coursework in their first year, and that students are instead more likely to be concentrating on completing prerequisite foundational STEM courses or other STEM courses that may not transfer to a 4-year college without fulfilling the STEM bachelor's degree requirements, right? So they're doing prereqs, that's what they're finding. And despite the potential of community college STEM transfer pathways to broaden access to STEM majors for underrepresented groups, such as Black and Hispanic students and women, the study found low and inequitable rates of early STEM transfer momentum. So what I want us to ask is our system in the California Community College currently designed to produce STEM momentum? And I want you to look at what we found when we looked at the 2022-2023 catalogs from our system and back in the fall 2022 class schedules. What you have, the height of the bar is the number of colleges. And what we looked at is the length of the most prevalent pipeline to calculus. We only looked at transfer level courses. So if a college had a single pre-calc intensive with embedded trig, that was one transfer level prerequisite. If it was the most prevalent pipeline, we counted it. So in other words, if you mainly saw them offering that pipeline when you looked at their class schedule, you mainly saw the pre-calc with embedded trig course, then we counted them as a college that had just one transfer level prereq in their pipeline. The vast majority of colleges in our system had a clear two course pipeline, and it was the most prevalent one. So just a huge number of college algebra courses, sections, trig sections, or something called college algebra then pre-calc, or those kinds of combinations. 87 of our colleges had the two course pipeline. And there were 9 colleges, 6 of which were not on the quarter system, that had a 3-course pipeline as their most prevalent pipeline. And we know from PPIC studies that only 18% of California Community College BSTEM majors actually start in calculus as their first math course, at least in fall of 2019. So the question really is, are we right now designing our system to produce STEM momentum? It doesn't look like our prevalent pathways are designed for students to be able to complete calculus in their first year. And if we look at the completion rates, the throughput rates at these different starting points, we can see that they are really low. So according to the PPIC study, looking just at BSTEM majors who enrolled for the first time in fall 2019, about 9,500 roughly students, if they started in college algebra as their first course, 15% completed some form of calculus within 3 terms, 3 semesters. If they started in trig, it was a little better, 20%. If they started in the intensive pre-calc with embedded trigonometry, it was 38%. But you can see here that not only are we designing longer prerequisite pathways to STEM that do not build STEM momentum, we don't have very good completion rates right now in our state. So when you think about attrition in a prerequisite model, if you're starting even with that intensive pre-calculus course, there's still 3 exit points, right? So statewide right now, according to PPIC, statewide, 46% of students who start in the intensive pre-calculus course with trig pass it. And now this is hypothetical, if 70% persisted to calculus and 75% passed calculus, we'd only have a 24% completion rate. So you can begin to see that these numbers are low because attrition really is inevitable. And even if you were able to get your pre-calculus success rate up to around 70% or so, you would still have an overall completion rate that would be in the mid-30s. Now, this is the other thing that really surprised me when I started trying to read about STEM momentum, is that many universities have done studies now looking at students who are denied access to calculus and are starting in a preparatory, like pre-calculus course. And what they have found is that students often who pass the prerequisite choose not to persist into calculus. In other words, capable students change their major. And it's rather shocking when you look at how frequently this occurs. So for instance, at Texas Tech University, 1/3 of their students who earned a B or better in their pre-calculus course did not enroll in calculus. At Arizona State, 65% of their declared life science majors who earned a C or better in pre-calculus did not persist into calculus. And this was true for 55% of declared physical science majors and 38% of declared engineering majors. So we can see that there's not only are they, even if they're passing the preparatory courses that we're putting in the pathway, so many students are deterred from continuing in their major, and they're changing their majors. And we've all know that there's a huge problem with students choosing very early in their STEM career to move out of STEM. Okay, now I want to go back to our sort of shared values, and I want to think about, are we really designing systems to produce STEM momentum? Because we all want students to we want more STEM students, right? But we're also worried, because we teach at a community college, about the students that we are deeming not calculus ready. So I tried to sort of look around at information about them, and I found a quasi-experimental study of over 10,000 student records And they were from 2- and 4-year institutions, but that was a stratified sample. And what they found in this study is that if a student took pre-calculus in college, that did not produce statistically significant improvements in the student's performance in calculus. And this was true for students with weaker math preparation and also for those who had previously passed pre-calculus in high school. So if you look also at the equity issue, the Mathematical Association of America has published an extensive study, a national study on college calculus. And here's a quote from their chapter on placement. Restricting student enrollment in Calculus 1 may result in students never passing calculus who otherwise might have. And furthermore, there is a disproportionately frequent placement of underrepresented minorities into remedial and pre-calculus courses. The meager gains from pre-calculus do not appear to offset the considerable risk that students directed to pre-calculus will not persist into calculus. And just to give you one peek, I looked at one college was willing to share their placement data with me. This is a college with over 70% enrollment as Hispanic students. And they were able to document a fairly large disproportionate impact on access to calculus for their Hispanic students. When they realized that, and they looked at their throughput from pre-calculus, it was 28% for a 1-year calculus completion for that group. And they are thinking in terms of the structures they have creating a racially disproportionate impact, right, on their Hispanic students. And this really is sort of a definition of structural racism. When we disproportionately place students of color into a course sequence that produces consistently low calculus completion rates. Okay, so I'm going to end there and hand things over to Paula and to Lisa. And I want to just say that this context was provided as a way for us to think forward about ways in which we can structure, restructure, rethink the structure of our calculus programs and give students access, but also provides the support that they need. Okay. So I'm going to stop sharing my screen and hand things over to Lisa and Paula.
Thank you so much, Myra. Go ahead and get my screen shared here. Okay. Hi, everybody. Thank you so much for coming out this afternoon. Just before we get started, I just want to take a moment to thank Myra for reaching out to me and sending me an email and getting just connected with me so you can find out about what's happening at Mount SAC with our calculus support courses so that we can share it with others like we are going to do right now. So thank you, Myra. My name is Lisa Morales. Yes.
I'm sorry. I was just going to say I put a link in the chat for a Google form. If everybody could take a moment just to fill that out while we're introducing ourselves. We want to get some idea of who's here today.
Yes, thank you.
It's just 2 questions. Sorry.
Oh no, you're good. Thank you for jumping in at that. I was just gonna mention it. So we are both from Mount SAC. We're both math instructors, and we were hoping to find out a little bit more about you, just for our own information of who's joining us today. But as you're doing that, I'll just briefly start by introducing myself. My background is a high school teacher. I was a high school teacher for 5 years before moving over to Mount SAC full-time. I've been at Mount SAC full-time for 7 years, and both Paula and I have led many math department community of practice events and events for the Natural Sciences Division, just a lot of PD for our Flex Day. So we are really just excited to be here to share what we've done in our class. So I'll turn it over to Paula to introduce herself.
Hi, my name's Paula Young, and like Lisa, I also started off teaching high school where I taught for 11 years. And then I did switch over to Mount SAC, community colleges in Mount SAC, and I've been here for 15 years. And along with Lisa, I have also, with her, co-led many of our department community of practice events. And we just wanted to start off by saying, obviously we are no more experts on this than you guys. in terms of the teaching of calculus. But we do feel fortunate that we've actually been offering a support course with our Calculus 1 class since fall of 2018. And we have had a lot of time to revise what we do and reflect and learn from our mistakes. And we wanted to share some of that with you guys so that as you're going through the process of creating these courses, maybe you can not make some of the mistakes we made, or learn from what we've done. So a few things before we jump in. We wanted to tell you just a little bit about the co-requisite course that we have at Mount SAC. At Mount SAC, Calculus 1 students, Calculus 1 is called Math 180, and our support for Calculus 1 is called Math 18A. And students who have passed pre-calculus in high school are currently eligible for our Calculus 1 course, and they can choose to take it with or without support. Both Lisa and I teach with a partially flipped classroom or a blended classroom. Most of our calculus material is taught through required videos that the students watch before each class. And this is not the norm with other calculus classes at Mount SAC. During our launch of these support courses, which again was in fall of 2018, our college did provide release time for a small cohort of math faculty to work on creating materials for these co-requisite courses. So we strongly encourage you to get some release time or support to help you with the creation of these courses.
Let me go ahead and jump into answering a couple of the questions in the chat. So our Calculus 1 course is a 4-unit course. And as I'm going to mention right now on the second slide here, our co-requisite is a 2-unit course. The support courses are hard linked to specific sections. So let me go ahead and go through this and see if it answers a few of those questions. So 2 units, it's a pass or no pass class, gives us the professor 2 extra contact hours with students per week. As I said, they are hard linked, so you can't drop one without the other, and it's tied to a specific section, so the same group of students are in both. The instructor can determine when to weave in support content. It doesn't have to be during the set time for the support class that is outlined in the schedule when students sign up. There is a specific class, but instructors have been given the flexibility to weave it in as needed. And our support courses are optional. So even though we call them co-requisites, right, as if there's a requirement, they are all optional. And there is no GPA band at all where they are required. Let's see. And let me just make sure.
Okay. Oh, there was a question about, are we sure that students watch the videos? And we will go over that on this slide, actually, I think, or maybe it's the next one. Yeah, this slide. So let me go over the general structure of a lesson in our Calculus 1 course with support. So in class, usually this happens kind of towards the end of class. So we will have finished up a topic, and now at the end of class, we'll review some 18A support notes is what we call them. That's our support class to get ready for a specific calculus topic. We have these for most, not quite all of our lessons. So this is the prerequisite topics that we have gone through and pulled out as ones that they will need for, Lisa, for the next topic. And then outside of class, the students will watch a video that we've created where it's us talking and going through whatever the lesson may be. They're tracked on Canvas using a company called Precalculus. That's how we do it. Of course, there's lots of other ones out there that do similar things. The videos include embedded multiple choice questions to help them kind of think through the concepts and see if they're understanding them. The multiple choice questions don't count towards the grade, but watching the video does count towards their grade. And then also before they come to class, so they'll watch the video and then they complete what we call a check your understanding, or we abbreviate that with CYU. And that is a couple of practice problems that are at about the same level as the video, and also a place for them to reflect on how they feel their knowledge of the topic is. They rate their knowledge, and then there's a spot for them to include questions. And then when they come into class, we review that, check your understanding. That's the first thing we do usually in class. And we ask if they have any questions on the video. And then at that time, there may be additional notes that we go over, or an additional topic that we cover that wasn't part of the video. And then at that time in class, they will have time. I would say most days I have at least an hour for my students to, that's for a class that meets twice a week, to work in small groups on the homework. And I walk around and facilitate what they're doing and help them out. And if time permits, we might do some active learning activity where they're going to the board or doing something else in that respect. And then also in class, we give them a small multiple choice Canvas quiz, because that's the system that our school uses, Canvas. And this is another chance for them to check their understanding of the topic that we have covered. And that kind of completes our cycle for that particular topic.
Thanks, Paula. I just want to address some of the questions in the chat. Do all students have access to tech to watch the required videos? Yes, so our computer labs on campus, we have a math specific computer lab on campus. They make it so that students who maybe don't have access at home are able to watch their lessons in the computer lab on campus. And we still also, I believe, have like hotspots available for students kind of post-pandemic that stuck around, thankfully. Just trying to see one of the other questions. Yes, the slides will be posted. In terms of proofs, yeah, so we still do proofs in the course, and of you know, everything in calculus, and the epsilon delta definition of a limit is covered. Instructors are currently paid 2 full lecture units. We are not paid at the lab rate. They are considered 2 full lecture units right now. Play Pause It is currently offered for free through our institution. It wasn't originally, but our Faculty Center for Learning Technology did acquire a license. I'm not entirely sure how much that was for the college or what the details were of that, but it was acquired through the college. In the past, I used to pay for it out of pocket, and it was like $150 a year. So I'm really glad that the school invested in that for us. And I'm going to go ahead now and show an example of this general structure of a lesson that Paula just described. So we're going to go ahead and show you the first lesson that we're going to go through here. I hope you can see it okay. Whoops, the first lesson we're going to go through here is our lesson on algebraic limits, just to give you a little bit of an idea. So what we have is we have what we call our support notes. So our course is Math 18A, so Math 18A support notes. And just a little bit of about an organizational tip. We put all of our co-requisite content, when we print it out for students, we put it on a different color, just because it can get a little bit daunting to keep track for students of both classes, so that they know what is actually part of the target course and what's part of the co-requisite course. So these notes for me, I make them in yellow. And so what is listed here is the topic. So this would be the prerequisite topic or topics that are needed for the calculus topic. So we have factoring, rationalizing, clearing fractions, and trigonometric identities. And all of this is support for the calculus topic of evaluating limits algebraically. And underneath that, what we have is a list of the key concepts. So that kind of just goes a little deeper than the topics list up here. And the main idea behind putting those key concepts, listing them out in a little bit more detail, is because we really are very briefly reviewing these concepts with students. As we said, that right now, the students who place into our Calculus 1 course have come from a pre-calculus background. So this support is, treated as a bit of review. But if students need additional practice outside of this mini lesson that we're giving them, we encourage them to look up these topics. We try to give them as kind of a detailed description of the topic so they could go ahead and utilize outside resources, whether it be pulling out a textbook and finding, the difference of squares in the index so that they can find some examples, or going to YouTube, which is the likely possibility, and looking up some additional videos if what we cover here isn't sufficient to catch them up in the review concepts. So we just have, very briefly listed the key concepts, a couple of quick formulas if they are short. So difference of squares, sum and difference of cubes, multiplying by the conjugate is the topic, simplifying complex fractions. And then very specifically, the two identities that we're going to be referencing on this page. So it's just a one page for this topic of practice problems that we go through. So we have a couple of factoring, and I will state that this is not the first set of support notes that we go through. So these factoring problems, we do go through some that have a leading coefficient of 1. Those are in previous support notes. So these, we've kind of amped it up in difficulty a little bit as we go. We have some quadratic form, right? A higher degree polynomial. We have a factor by grouping, another quadratic form, but with exponentials, GCF, where there's an exponential. On part G, you can see, that double angle identity needs to, be known in order to factor this. And then we have that sum of cubes. So, it's that idea of just-in-time support. So the formula you needed, we're practicing that formula or identity. We have rewrite the expression by multiplying by the conjugate of the numerator. So if you teach calculus, you all know the application of being able to multiply by the conjugate. And then we have simplify, two different examples here, one where you can combine fractions or clear fractions. And, in this support notes time, in this like mini lecture time, I do go through both options. I take the time to go through both ways that you can do this. And then here, there's kind of two layers. You have to know the identity, the Pythagorean identity, rewrite it so that you can factor and then cancel with the sine x over 1. Although the way that it's going to work out is it's not the exact same factor in the numerator and denominator, right? It's going to be like 1 minus sine x and then sine x minus 1. So we really kind of tried to consciously choose examples that were layered so that we could, in a short amount of time, review a lot, right? And give them that exposure and try to remind them as much as possible of the different things that they've maybe seen along their math path. And then each one of these ends with a little self-reflection. So we are really big on having students pause and reflect on their knowledge so far. So when we're done, asking them to rate their overall understanding of these topics. And this rating is really for them to just pause and think about where they're at, give them a chance to write some notes to themselves. So, oh, I'm fine with factoring, but oh, what did she call that? Rationalizing, I need to look up a conjugate, whatever it may be, they can take some notes for themselves. So they would watch this. They would watch us lecture on this, maybe towards the end of a class. And then before they attend the next class with us together, they would watch the video lesson on the calculus topic. So here are our Calculus 1 notes for the topic of evaluating limits algebraically. We do provide the reference to what part in our Stewart textbook they would maybe want to go ahead and take a look at if they had the book, but we don't actually require the textbook in our sections. We do have all notes packets and homework packets provided for students, so they don't need the textbook, but if they wanted to purchase it or had a copy, this is where they would go in the book for reference. And so here, the little play symbol tells them that this is a video lesson. So this is where the content of the video starts. And then there's a stop button, which I'll scroll down to eventually, that shows them where the video lesson ends. Now, all of the topics are not all covered in a video lesson. We may need to finish it up in class because we're trying to limit the videos to not be really, really long. But that's the play and the stop buttons. So without going through the notes with you in detail, I just want to kind of show how the problems that we have are the algebra behind it are things that we have touched upon either in a previous support notes section or in that very recent support note section. So, here we have the difference of squares, and it's a very straightforward difference of squares type of problem. I'm going to scroll down a little bit here. So here, there's two things: factoring out a greatest common factor and then the difference of squares. We have a multiplying by the conjugate type of algebra question. Here we have, either clearing fractions or combining fractions. Here, combining fractions, common denominators. And then these last two examples, use some different strategies. So they use a little bit of trig identities here. And this one, we go ahead and do a sort of a graphical approach to the problem. So we have kind of exposed them either in a previous support topic or right before it, the immediate support notes topic. We've reviewed it. Then they see it again in this video lesson. And after they complete the video lesson, there's that stop sign, right? So they finish the video lesson. Now what? So what we do at that point is ask them to complete the check your understanding. So again, a little reflection. So after watching that video lesson, how well do you feel you understand the material presented so far? So this is where, again, they give us that, hopefully honest reflection of where they're at. And then we ask them to, use their notes to help them complete the following problems. And so there are problems very similar to what was covered in the video lesson: some factoring, some rationalizing, some more factoring. And they also had some embedded questions. This was something Paula mentioned. So in the video, in the software that we use, it gives us the ability to pause, ask them a question before they can continue. So they're just getting a lot of refresher, a lot of practice on both the prerequisite content and the current calculus content. And what questions do you have so far on this lesson, if any? So it gives them a chance to think about any questions they had after the video. And then the last thing that we wanted to go ahead and show you is the corresponding assignment. So the homework assignment or the practice that we would give them for the calculus class. So this is for Math 180, the assignment that goes with this algebraic limits topic. I'm going to skip over this reflection part for a second. I'm going to just look at the problems and then I'll go back and talk about it. So here we did, just over the course of time, refine our homework assignments, created them ourselves, typed them out. So again, really trying to show the same algebra techniques again that they've been reviewing and refreshing themselves on throughout all the different activities we've done so far. So we've got some factoring. Here we have multiplying out, which wasn't explicitly covered in these two, but it is something that we've covered previously. So they've kind of seen before distributing here. Another conjugate, factoring cosine squared minus 1, sum of cubes. So just a lot of that repetition. So by this time, I feel like they really have a good grasp on things. They're able to jump in and kind of start working on this, and they work on it together in groups. If there's time, they go to the board and write out the solutions, and we talk about, maybe common mistakes that we see. And at the bottom of the assignment, the bottom of all of our assignments, we have what we call spiral review. So I think one of the advantages of kind of creating your own homework assignments is that, you know, you can pick some review problems to put on each one so that they're seeing that content again, those previous lessons. So before algebraic limits, they haven't seen too much. So here, you know, we have like an infinite limit, right, type of problem. So we have kind of 2 review problems from the previous section, and that is at the end of every assignment. Oh, we have 4 problems, right? So a couple of problems here. So I'm going to go ahead and go back to the required reflection part now and just kind of explain what's going on with that. So what we tell students is that, you know, we want them to work on this assignment. If needed, use your notes, right? And then use your resources, as in the people around you. You can ask us for help because they're doing this in class, you know, working in groups, hopefully with, you know, that low pressure and feeling like supported, that they can ask questions. So we want them to try these problems. But when they're done with their assignment, it is a requirement for them to go onto our Canvas page where we post the full and complete solutions to the entire assignment. So not just the answer key, but the full worked out solution for every problem. So it is a requirement to go back and basically check your work. So after trying each problem, they are go back and review and put a check mark next to the problem if they were correct. If they were incorrect, to put an X and write the full correct solution. And if they still aren't understanding the problem, because of course you can just copy it down, but still not really understand it, then circle the problem if you're still struggling to understand that problem. And then do a little bit of an assessment, right? How many problems are you still, or reflection, how many problems are you still struggling to understand? And so they would put that number here, you know, I'm still struggling with 2 problems, and maybe that means their current level of understanding in their mind is that they have a B. And this is a requirement for submission, but it's not part of the grade. We still give them full credit on the assignment, even if they're not understanding 10 problems and they have a D level of understanding, right? It's more, we tell them for them to go back before you take a test to look at this assignment and say, hey, you really didn't understand this topic. Remember algebraic limits? So that's something that you should review before you take the test, right? So it's really more for them to be able to gauge where they're at in terms of their understanding on that topic. I'm going to go ahead now and pause. And I'm not sure how much Paula has kind of been able to address anything in the chat, but I just want to give her a chance to maybe if there are any.
Yeah, I'll address, I don't know exactly when people posted these questions, so they may feel like their question has already been answered. But this class is 4 units and the co-requisite is 2 units. So that's a total of 6 units. And somebody asked about how a typical class goes. So as we said, when we come in, we do the check your understanding. We ask if there's questions on the notes, and then we go right into working on this lengthy homework assignment. So they're doing that in groups with us there walking around and helping them through that. They might possibly will be doing some other activity related to that, where they're going to the board or doing something with the problems that they're working on. And let's see, somebody asked what book we use. So it said Stewart on there, but neither of us require the book for our students. If you have, okay, do you? Okay, so that basically answered that question. We do make the videos.
Sorry.
Yeah, we do not use WebAssign. We do make the videos on our own. Lisa did a majority of the 180 videos, but sorry, the Calculus 1 videos, but we've also done the same thing together for Calculus 2, and we kind of did half and half of the videos for that course. What do we do with the self-reflection information? It's really for them. That self-reflection is for them to kind of look back and go, okay, there were 10 problems I didn't understand from this assignment. I need to go to the tutoring center or office hours and get some help on that before the exam, so that I know how to do those sorts of questions. I think that was a majority of, we don't use, is there a copyright issue? We don't use Stewart lectures. We make up our own problems. Some of the problems we pulled from various textbooks. I don't think you can copyright functions, or so I'm not sure if that's an issue with that. But the notes we did kind of all on our own. What level? Okay, so right now, the class is only open for students who have completed pre-calculus, whether that be at their high school or at our college. Obviously, next year that will change. So that is going to change possibly what we do. We don't know how that will work. And I guess that'll be new territory for all of us. So I can't see any, I don't see any other questions. Sorry, I just very quickly skimmed as you were talking.
Paula, I wonder if I could just add to that, that right now your calculus co-req is an optional. Students can choose to take it, but to get into calculus, either with or without support, they've passed a pre-calculus course in high school. So I wanted to point out that this is not very common in California. When I have looked across the research that I could find, for instance, students who have completed pre-calculus in a California high school are twice as likely to be enrolled in some form of pre-calculus at the community college as their first course, which could even be college algebra, than they are to be enrolled in calculus. And so if the pre-calculus completers statewide, I think about 13% of them take calculus as their first math course. So I think that some of what we're talking about here today is going to be very relevant to colleges who are needing to broaden access to calculus to high school pre-calculus completers, right? Because those students have been largely barred from starting in calculus at many colleges. So I think a lot of what you're doing is completely directly relevant to the experience that many colleges and community colleges are going to find themselves in. The other thing I wanted to say that I wanted to see if, and maybe you're going to do this before the end, but maybe going back to that very, very early slide where we can just see the lesson cycle again, because I was trying to get sort of the rhythm of how often within a very short period of time, students have these practice opportunities. So I'm hearing you sort of backwards design from calculus, like what are the pre-calculus or algebra content, topics we need for the calculus that's immediately coming up. And then, yeah, if you could just sort of run through that again, because it seemed like the student is getting an opportunity many times to attempt things, get direct instruction, reflect on their learning, compare their answers. There's just this a more iterative cycle, it seems, around reviewing that maybe we would see in a typical classroom. So maybe we could just run through that real quickly. Again, I think there were some questions about that.
Sure. So I hope I'm sharing the right screen that you're referring to. So yeah, we can review this again, and then Paula's going to go through one more lesson that kind of follows this format. So, traditionally it would be towards the end of a class where the instructor, where one of us is going to review the support notes, right? So that would be the prerequisite content that is needed for that video that they're going to watch in between the next time we're going to see them. So then it is outside of class that the students are going to watch that calculus video lesson, and it may be the entire lesson, the entire calculus topic, just depending on what it is, or it might be the majority of it. And then when we come to class, we'll finish it. And these are tracked on Canvas using that website we described, or that software, where we can also embed some questions in there as well. So there's some embedded multiple choice questions within the video that don't count towards the grade. It's just another check for understanding. But watching the video does count towards the grade. And these embedded questions, it's a bit of a mix between the prerequisite concepts and the current topic that is being explained in the video, just kind of depending. And then still outside of class, students are asked to complete this one-page check your understanding after watching the video. So that moment to just reflect and try it, right? Try it on their own, see where they're at. Because it's one thing, of course, to watch someone do it and another thing to do it yourself. And then when we get back to class, that's when the instructor reviews that check your understanding. So they would have it in front of them and they could see, you know, we go through the answers and they can kind of check like, okay, yeah, I was on the right track. I got these 3 right. I feel confident in starting working on the corresponding full assignment. So they get a chance to ask any questions. So if they didn't get those questions right, they can ask clarifying questions. Again, there might be some more calculus lecture. And after that's done, then the students start working in groups. So they're working individually on their own assignment. I guess I should mention that. So they're responsible for turning in their own individual assignment on that topic, but they're just working collaboratively. So, you know, being able to ask questions of, you know, the people that are next to them. And then just depending on how much time we have, and it's great to have the support class time, we can do a lot of other things like have students go to the board and write out their answers to the assignment questions, or just a lot of other activities that we don't have time to share today, but we have a lot of other active learning activities that can be done in this time frame. And then we do try to give them a little, I don't want to say quiz isn't like a high pressure quiz, but we do want, it's almost like an exit ticket, but online. So a little exit ticket on how did they understand that content before they leave today. They're going to practice as an individual, as if it was a quiz, but it's not, you know, the pressure of an actual quiz.
So one last question then, the majority of time that you're with the students in the face-to-face environment, it's an interactive learning environment. Their work, there might be a little lecture, but it's mainly them practicing things in groups or them up at the board doing things. And you use, do you use the 360-degree whiteboards? That was another question we had, or are they mainly working in groups at their seats?
I would say they're probably mainly working in groups. I mean, I think Paula's class might be slightly different. I don't know, but they're mainly working in groups at their seats. And then if there's time, they go to the board. And by 360 boards, do you just mean there's whiteboards all around the room, or is that something? Okay, so yeah, so there are whiteboards all around the room. And then when they go to the board to write up their problems, yeah, they kind of go all around the room. And then it's a chance, it's just so nice to have that extra time so that we can go up to a question and then, you know, I just did this the other day where we were talking about the importance of, like, when you take a derivative, making sure that you use correct notation. So they kind of just want to take the derivative and put equals, equals, equals. So it's like f of x equals, and then equals, equals, equals. And at no point do they put f prime of x equals. So when they put questions up on the board like that, it's like a whole learning, you know, experience, of course, because we can learn from our mistakes, and then setting the culture that it's okay to make a mistake. And that we're all going to learn from that mistake right now in that low pressure environment.
So one question. Oh, sorry.
I was just going to switch over. So you can...
Okay, go. You can switch while you're switching. There was one question somebody asked, how much credit do you give them for watching the videos? I think that Lisa and I may do this for, I don't know what she does, but like, let's say a homework assignment for me is 4 points. The video is 2 points. So you get 2 points for watching the video and then 4 points for doing the homework. I don't know what you do, Lisa.
The same.
Oh, okay. And then again, that's part of the homework grade, all of those points, which is 10% of our overall grade. Or no, 10 or less than 10 or less, 10 at the most, according to our department. Our class size, I think I answered that, but our max class size is 36.
Mm-hmm.
Okay, so I'm going to talk a little bit now about the lesson. How many students? Well, right now our 180 and our 18A course is only open to students who have already successfully completed Precalculus. So it will not be open entry until the fall. So we do all this with students who already have either at their high school or at our school or another community college completed the Precalculus course. Okay, all right, so I'm going to talk a little bit now about another topic. This is the chain rule. So you kind of have already seen the cycle that we go through. So I just wanted to kind of highlight a couple of things. This is the same cycle here. The students come in and this would be something we would go over with them in class. So again, we have the topic. We're going to talk with them about decomposing composite functions and more. This is support for the chain rule. So the key composition, or the key concepts here are composite functions, decomposing a function, operators with functions, factoring out a binomial expression. So those are all things that we, when we looked over our chain rule notes, those were the things that we thought the students needed to review before we went into the chain rule. And so we go through some here where we give them a composite function and we ask them to take it apart, give us what's f of x, what's g of x. And if you want to scroll down there, Lisa, sorry. At the bottom there's we ask them to decompose a nested function here where there's 3 functions and tell us what f, g, and h are. And I believe that's the only, oh, there is a second page there. Okay, there's a couple. Sometimes students have issues determining whether a function is a product or a quotient or a composition. So we go through a couple of problems there where they're having to think about that. And then another thing that they sometimes need for the chain rule, or to maybe not use the chain, or to use the chain rule, or maybe after they're simplifying their derivative after using the chain rule, is to be able to factor out a binomial factor. So we go through a couple of problems where we do that with them. And go ahead and scroll down a little more, Lisa. And even with fractional and negative exponents as well, we go through some of those. And this one is, you'll notice, longer than the support material for the limits. That was only 1 page on the front. So this is 2 pages, like the front and back of a paper. And then we get into the actual notes. So you'll see again that play symbol. So this is where the students would start with the video. So this would be, we would have done those first 2 pages with them in class, and then they would leave and go home, and at some point before the next class, watch this video. So Lisa, just feel free to scroll through that. I mean, this is just some basic or some chain rule examples. They do get a little bit harder as we go through here, where we have to also incorporate the product rule and the quotient rule. And then even if you look at this letter D here, that one's got lots of stuff going on there. So that shows you we do get kind of advanced with some of our problems. This one, we kind of remind them at the bottom here of some trig identities, or just trig basic notation that we use. We do give them, we didn't mention this, well, I think we're going to mention it in a slide later, but we do give them at the beginning of the semester a packet of kind of prerequisite formulas and graphs and just things that we are, some of it we do review with them, but those are like things we refer to a lot. So we'll go, oh, we need a trig identity. Let's look in our packet and see where we have trig identities. Or, oh, this is the graph of x squared. We all remember what that looks like. Let's look in our packet, or the graph of sine, or the graph of arctan, or whatever. And we look at that in the packet and go, okay, so, you know, here's what our graph looks like. This is, where's our limit here? What's happening as we're going to infinity, or whatever. So, and then we have our nice little pie chart there just as a reference for them to kind of see. And then, so that's when the video is over. And then before they come to class, again, they'll do the check your understanding. So this is, again, as Lisa already described it, it's just a couple of questions that we give them to kind of make sure they're on the right page. Now, both Lisa and I use Canvas exclusively for our students to turn in things. So they will submit this to us via Canvas before they come to class. And then they'll be able to have it out on their desk when they get to class. And if they do need to make corrections, they can do it directly on the document, but it's already been submitted. So then we'll go through these, or sometimes we might have students go to the board and do these, or whatnot, depending on how much time we have. And then down below, the 3 questions down there, which I'm realizing the numbers were a little weird on those, but we'll just ignore that for now. We have them figure out what derivative rules they would need to apply there. So we tell them they don't have to do it, but they just need to think about what rules they need to apply. And then when they come to class, we'll go over that. And then again, they'll break into groups and they will work on the assignment for the chain rule. So this is similar to what you saw in the past with the reflection at the top that they'll fill out at the end after they're completed, and they'll work in groups on these questions. And then when they may not have enough time in class to finish the entire assignment, because it could be that we need to stop and move on and talk about another topic. So there will be time when there's 2 topics discussed in one class. So they'll spend 15-20 minutes going over the check your understanding, and then we'll do the homework for an hour possibly. We'll end that time with a quiz where they are on Canvas, just kind of, again, checking their understanding on that, making sure that they understand it. And then possibly we'll move on to a separate topic. And then that separate topic will be something we will discuss or lecture on in class. And then the homework for that one, most likely we don't have time to start it. They will do that one outside of class. So some days we'll go over 2 topics. Some days there's a video they watch, and then we need to kind of continue on in that same topic in class. So there's really only one topic per se, but we just expand upon it or do more of it kind of in class. So it depends. And then also we'll take time in class to do the support topic for the next class. So there'll be a time for us to then discuss whatever we're teaching the next day or the next class meeting, or they're going to watch a video on before the next class meeting. We'll do the support topics for that towards the end.
All right, thanks, Paul. There was a question earlier that I think I want to address out loud. So one of the questions was whether we test on the prerequisite content in the calculus class. And the answer is no. I mean, we test on calculus in the calculus class, but there is a separate pass, no pass grade for the support class, which is where, we would assess any of like the prerequisite content. So I know that none of my actual calculus exams have just prerequisite content in it, but of course it's obviously weaved throughout the problems. Okay, so now we just have a couple of final slides that just kind of summarize some extra things that we feel like weren't necessarily sort of talked about here. Maybe we'll answer some of the additional questions. So just some overall suggestions that we have based on things that we have found success with. We really think that our partially flipped or our blended class allows us for more time for that group work and the active learning activities, and for students to really form a community. I think that I really have a group of students who I hear them say, okay, we'll get lunch and then we'll go study together. And I think it helps start that community that they can then continue out of class. We as in Paula and I still do the blended model, even without the support course, because even then it gives us a little bit more time to have students work together to go to the board. But of course, with the co-requisite time or the support course time, it's even better. I did allude to this already, but we provide the homework solutions so that students are reflective of their strengths and weaknesses. I think we also know too, this is something in the chat, that they can probably get these answers through a ton of other sources now, right? ChatGPT, Wolfram Alpha, list all the things, right? So, why go there when you can come to us and you can see your instructors fully complete worked out solutions, step by step, so that you can find your mistake and identify what went wrong and what didn't. And our homework only counts for about 5% of the grade. The videos and the homework together, it's like about 10% at most, like Paula said. So the real benefit there, and they're explained that is in the process of learning, right? If you just copy everything, it's just like if you copy it from an outside source or from us, it's not going to help you pass the test. So learning from your mistakes when you're seeing that written detailed solution. faculty have reported success in our support classes when they require their students to submit their written notes. So I do this personally. I know Paula doesn't. We all have different styles, but one of my colleagues said that they started collecting notes from videos and that they felt like it really helped. So I started doing that too, and I agree. I think that it helps because they, you know, maybe about half of them in the past, if you didn't require it, would come in with a blank set of notes. And then when they go to get started on the assignment, they think they knew what was happening. But if, you know, they actually see their written notes, they can reference it. So I started doing that, and it helps. We give, so Paula and I give a Math 18A, which is the support class exams. And I'm putting that in quotes because they are on Canvas and they are multiple choice. And this is the exam on the prerequisite support topics, but before each calculus exam. So all of those support topics that we, you know, lectured on and that they practiced throughout the calculus assignments, now they're going to get a chance to practice that right before their in-person, in-class calculus exam. So that, you know, that hopefully that's not someplace that they will stumble upon or stumble with on the actual calculus exam. But we also know that there are some faculty who require students to complete an exam review as part of the support class grade. So kind of in lieu of that, we instead just give them this like multiple choice exam right before their actual calculus exam. But, you know, we've definitely heard of success by having students complete the calculus exam review in the support course. And then we do assign our final in the co-requisite course or the support course is a very lengthy Math 180 calculus final exam review. And then to this, we do not give the full solutions, but we do give the answer key. So that, you know, by this point, we want you to be able to work everything out and get the full solution, but we are going to give you the answer key so that you know if what you did was correct. So it is that work that we're grading. We're making sure that they did the entire thing. I think it's about 30 pages, or I mean 15 pages sort of front and back of just kind of all of the calculus 1 topics. So those are some of the things that we feel like work for us or our colleagues that we've kind of chatted with in terms of calculus support.
Lisa, I'm seeing one question from Scott that I think would be helpful to help you have you just reflect on. I know you mentioned so I'm looking for, there it is. You already sort of addressed that. Paula said that as your calculus with CoRec becomes open access in the fall, that you're anticipating as students come in and you see where they are and what they're struggling with, you're going to have to make changes. And we know you've already said that you'll wait and see what, and you obviously are both good at working on your feet, right, to respond to where your students are. But could you, for Scott and others' benefit, think a little bit ahead there when you're thinking of your current structure of the way you structured your course or the kinds of materials you're providing? Are you anticipating if you have a set of students who have not had pre-calculus before that there would be a big change in your approach?
You know, I think right now, I'm just going to speak for myself. I do think I already have a mixed bag of students with different abilities, because as much as someone could have a transcript that says they've taken pre-calculus, I think a lot of students are very forthcoming about that experience wasn't all they had necessarily hoped it would be, especially during a pandemic. So they kind of are aware that their what is on paper isn't reflective of what they know. And when they come and they talk to me and they say, you know, I had it just this semester, I like, wow, I don't know if I've ever seen this before. You know, my suggestion is always like, well, you know, you need to stop and think about, you know, how are you going to fill in the gaps here? Have you really never seen it before? Or have you seen it and you kind of, you know, don't remember it, you just need to recall the information. And I've been running a flipped classroom since I was a high school teacher. So since I taught AP Calculus in high school, I have a huge collection of video lessons. So for me personally, I tell students, if you need videos on pre-calculus content, so the full development of trigonometry I have in video form, so I point them there, you know, but it's, I mean, it is obviously tough and probably overwhelming, but it's like, well, you know, this is where you can go to make up for whatever issues that you may be having. But there is no way, I mean, I don't want to be unrealistic here at all. There's no way that we can teach a full calculus, pre-calculus course and calculus course in a 6-unit class, right? Like that's, but I hope to just provide the resources and make them available. And, if a student wants to challenge that and tackle that, then, I support them in that.
So one question I have is that I often hear calculus, this is related to Scott's question, calculus instructors often will say, my students can do the calculus, it's just they're struggling with the algebra. And I always find that an interesting comment because we're sort of saying they can achieve the learning outcomes of the calculus course, but those outcomes are maybe perhaps confounded by a large amount of algebra that we do. So I'm sort of wondering if your experience in this sort of just-in-time integration of, we're going to take these skills out and teach them ahead of time and then come into the calculus and use those skills immediately the next lesson. Do you feel that motivates students to learn the algebra and that they actually work harder at the algebra in the context of calculus that way, rather than having it
Let me try and answer this. I don't know if this is necessarily. I do feel that when I show my students the algebra concepts that we're reviewing, and then I show them the calculus and I go, look, just yesterday or 2 days ago or whatever, we learned or we reviewed multiplying by the conjugate, and look, here it is in this limit, or look, we talked about multiplying out a binomial raised to the third power, last time. And look, here it is in the limit definition of a derivative. We have to multiply x minus h or x plus h cubed, so they're seeing the connection. Here is an algebra concept. I'm not just teaching you this because I think you need to know it, but look, you do need to know it. See, right here is where you're using it. And I think that when they see that connection, they're a little more inclined to, okay, this is where I need, I need to know these algebra concepts because I'm going to see them next time in the calculus.
Well, certainly by looking at examples you provided today, I didn't feel at all that it was a algebra-like course, right? There was all the full regalia of the kinds of algebra skills that we typically embed within the calculus. Let's see if there were other questions. Did you have more to present, or shall we just go to questions?
Yeah, we do.
Okay.
So I'll let me go through this slide. So some additional student resources that we have. I did mention this before, but we do provide a 180 prerequisite topics handout as a reference for students the first day of class. This includes things like geometry formulas, trig identities, graphs of basic functions, and a short review of some algebra concepts. So we do give that to them, and we do refer to it a lot during the semester. So students will go, oh, okay, she's already referred to the graph of arctan 3 times and drawn it on the board twice. So I need to make sure I know what that looks like. At least that's what I'm hoping they think in their brain, right? And we do have what we call STEM student success modules. These are made in Canvas, and they were made by a group of 5 Mount SAC STEM faculty, and they cover some of what we call the hidden curriculum of college. So for example, they talk about time management, active versus passive studying, how to deal with test anxiety, how to avoid distractions, how to manage your time, different things. I already said time management, how to just different things that students tend to struggle with as they are moving from high school to college. And we kind of want to make it apparent to them that we care about them, their whole person as a STEM student, not just their math ability, but also their just ability to be a successful student. And we really have gotten some positive feedback from our students for these modules in terms of that they've picked up, little things here and there, just in terms of, how they need, what are better ways to study. And boy, I've really been studying passively my whole career as a student, and I didn't even know that that wasn't effective, and just different things like that.
And then finally, we just thought we'd share just some of the changes that we've made over the years and what we've changed because we didn't feel like it worked. We sort of went back to our old content in preparation for this today and remembered, oh yeah, what we used to do is we did this before each chapter. So kind of before, teaching limits, right before all of derivatives, we might have spent an entire day going over all of those different topics that you needed for that unit. But it was just too much. I mean, in the same way that, a student may have seen the pre-calculus content in high school or a few years ago, whether it's a few years ago or apparently a few days ago, they still kind of forget. So we found it more effective to switch to just those shorter lessons for like that just-in-time support review right before that information is needed in the calculus lesson. We also used to have written assignments for the support class as well. So there would be a separate calculus assignment and then a support for calculus assignment. But it really ended up feeling more like it was busy work for the students and sort of took away from the time working on those more important assignments for the target class. So we, removed those, and now just every time we're thinking about making changes, the motivating question is just how does whatever this activity we're doing support passing the target class? Some change that we're thinking about making, I feel like we're always thinking about changing things. When we finish a lesson, we chat, how did it go for you? But changing our homework to have a ratio of more like 70% on current material and maybe 30% spiral review. We really just think it's important to circle back. They might be doing well on each individual test because it's so recent, but the final, I don't know about you, but I always feel like what happened on the final. And so if we keep building in more spiral review on those topics, that may help. And just to keep track of changes after each lesson, we have like an ongoing Word file to think about. Do we need more or less support content? Should we change the pacing or the order of the topics? So those have just been things that we've, done over the years. And to sort of wrap up here,
We have one more slide. Yeah, we'll talk about the future of calculus at Mount SAC. So right now, the plan is to allow STEM majors to place directly into Calculus 1 or Calculus 1 with support. We are still offering 2 pathways to calculus. We have a 2 sequence of trig and pre-calc algebra, or a 1 course option that is combined trig and pre-calculus together. Since we don't require our students to take calculus with support. Oh, you know what? This reminded me of a question I saw in the chat that I forgot to address. Somebody mentioned, what if they just don't show up for the support class and they just take the target course? Well, there are lots of sections of regular non-co-requisite calculus offered at our school. And then there are some sections with the co-rec. If you sign up to be in the co-rec class, both of the classes are required. And we do weave the information. We're not only doing co-requisite topics during the time slot for the co-requisite class. So it is weaved in throughout the class as just-in-time support. So basically, it's just a longer class that we can choose when we want to teach what in terms of the calculus versus the co-requisite material. So they do get a grade for both. So I hope that answered that question, but we don't require them to take a support class for calculus. There's not a GPA band where we say you guys are required and you're not if you're above it at our school. And so we are in the process this semester and last semester, a group of 5 of us, of creating what we're calling the Math Jumpstart modules. These will also be in Canvas, and they're to support students who enroll in just 180. And we're doing this not just for 180, but for other math classes as well, our statistics class, our college algebra class, pre-calculus class, and possibly our business calculus. We haven't decided or figured out if we have enough time for that. And those are, this was funded through a SEEP grant that we got. And in that class, or in those modules, we do go through some of the same concepts that we showed you today in our co-requisite, but we think that the calculus support course would be a better model for students who recognize that their pre-calculus skills need refreshing. But those modules are intended for instructors who want to embed them in their course, their non-support course class, if they possibly would just make them optional, or whatever they feel for their students if they would like to do that. We currently do have a Calculus 2 support class as well that we have both taught using a similar model to the one that's shared here, and we found a lot of success in that. That class is just so, as you guys know, so trig heavy, whereas Calculus 1, we feel like students could slide by with not much trig knowledge or support, just memorizing a couple things. But Calculus 2 is so much heavier when you start talking about integration and trig substitution and that kind of stuff, and all the various strategies that we look at there. And so we feel like even more than Calculus 1, that Calculus 2 support class is just really beneficial for our students. So that's it. Just wanted to say thank you. We do have another webinar coming up on Friday, April 14th from 1 to 2:25. And that we're going to talk a little bit more about the creation of our cycle and how we decide what questions to put on our co-requisite support material. And that hopefully, as you guys sit down to do this, will help you to kind of, if you want to think about it the way we do, to think about it in a kind of backwards. We kind of do a backwards model where we create our lessons. Lisa, did you want to add anything more, or did you have any questions that you saw that you wanted to answer?
No, but I just realized it's from 1 to 2:15, right, Myra? Sorry, that's just.
Okay. Slide is wrong.
That's okay. Well, I wanted to thank both of you so much for coming today, and to say that I think we are in a space right now where we all need to deeply question what we're doing and learn. And I saw within the chat a few people with great incredulity about the direction that AB 1705 might be taking our state. And I want to reassure that several people said their local data was not showing what the statewide measures were showing. I want to tell you that AB 1705, as you know, is a database research-based law, and it focuses on completion. So if you have something that is working, you will be able to keep doing it, right? And there is a lot of technical assistance that the MMAP group and the Chancellor's Office provides to researchers. So if you've got something that you feel like you really want to show improves students' completion of calculus from where they start through actually completing that gateway course, you can do it, right? You can submit that data. I also want to go back and emphasize that I think it is hard for us as mathematicians. I think I see two things happening sometimes in our thinking. One is that we really focus on prerequisite, like math as sort of a ladder of skills. And that is not necessarily the way students learn. So even though we can create a huge concept map that says, if you want to do this, you got to be able to do this first, and then you got to be able to do this first. We have a lot of examples in the last 5 years of working on AB 705 where students are able to learn something at a higher level, right? Even if they don't know something coming into that learning experience. So I think we need to try, why we're moving forward here, to take ownership of the fact that right now in the state, the vast majority of our colleges have a structure of prerequisites to calculus that preclude students from building STEM momentum. And this is a very serious thing. If we don't own this, and understand it, it is going to be very difficult for us to actually produce larger rates of STEM completion, more diverse rates of STEM completion, and transfer momentum. So I think if we go back to the values that I tried to start with today, those are shared values, and our current system is not producing what we say we value. So we need to deeply question and try to figure out a new way forward. The other thing I wanted to say in closing is that as I'm listening to some of, and it's just a few people in the chat, I am concerned about our mindset. And some faculty, I think, are operating from a mindset that this is impossible, or we can't do it, our students can't do it. And I think there's also a questioning deeply about whether we as faculty can figure this out. So there are many studies that have been done recently around the impact of our mindset on our students. And we know from Mary Murphy and Canning and that group, they have done studies that have shown when faculty, STEM faculty, have a mindset that their students cannot achieve what they have set out in the classroom to try to achieve, guess what happens? Bigger equity gaps and lower success rates. So it's going to be a self-fulfilling prophecy if we don't try to take this on with intellectual integrity and creativity that I know that we have within our discipline. But we have to own the problem, and we have to say that we are going to try something radically different in order to achieve the values that we all share. And I want us to believe in our own capacity, just like we believe in our students' capacity. I think that we can do this, but if we can't, it's okay, because the data will show it, and we will be allowed to continue structures that only get 15 to 20% of our students through calculus, right? But I think we can do better than that. And if we're going to do better than that, we've really got to embrace a redesign, and I think we've learned a lot today from Paula and Lisa. The backwards design idea, the just-in-time integration of prerequisite skills, the repeating of, here you see the prerequisite skill, here you practice it, here you see it the next class period, here you reflect on it, here you look at your homework, right, relative to a full worked out solution. So we need to think about those lesson cycles. Like, are we building opportunities for students to practice and then practice again and get feedback and practice and reflect, right? It's those kind of learning cycles that are not typical in our classrooms, but hold the promise, perhaps, or a piece of the promise of trying to create classrooms that can accelerate students' learning and get them through with deep knowledge in the calculus sequence. So that said, I want to thank you again, Lisa and Paula. I know it can be challenging to be in front of your colleagues presenting something, particularly when we're in a period of time where there is a lot of, I don't know, stages of grief is what it looks like to me, you know, sort of anger, denial, bargaining, and then maybe we'll get to acceptance and be able to move forward. So I appreciate you stepping out at my invitation today to share what you've been doing. And I always appreciate the growth mindset that you both have, the constant reflection and changing and thinking about what your students are experiencing and whether it's working. So on behalf of everybody here, thank you again. And we hope that we will see folks at the second webinar where we'll get more into not what they're doing, but sort of how they thought through it. And maybe then we can have more constructive discussions around, okay, if that's what we're doing for someone who maybe's had this before, what if they haven't, right? So what would we do then? Okay, that said, thank you, everyone. We will sign off and hopefully see you at the next webinar.